All right, so day 4 for this week, we are going to start looking at facades and hardware applications. So I'm going to show you two primary methods. One of them is less accurate, more malleable. The other one is more accurate, it's a little less customizable. It has a little less flexibility. Okay, so basically the high level understanding of what they are is this. Using Boxmorph, you can locate all of your hardware to particular locations on the actual definition. And so that can be a subdivision of a panel using your domain reparametrization, which is the easy way, with a lot of flexibility, but not quite as detailed. And then the other way is to actually locate a point and a plane and direction and use exact dimensions to generate where that hardware is going to be. So it's a lot more accurate, but it's also a little more difficult to work with and can become more complex depending on what kind of hardware you have. Okay, so that's the general principle here. But to get started here, I think what we should get started with doing is setting up the actual surface that we're going to work on. So I made this thing. It's 50 feet wide by 100 feet tall. Okay, so I tried to make it something that was significant but not too overwhelming, right? And that's the void space in between. So the other thing that I want to do is I'm going to make it a little easier on myself here and put a 4-point surface in there that I can use to reference for my glazing. And I'm just going to start with one surface as my definition for everything that I do here. So I would put it on a separate layer, so something like that, put it on layer 1, and then you can just run your 4-point surface to all 4 corners, and I suggest push back a little bit. I think we did this before. And before you maximize your Grasshopper again, just reference that surface in, and then you can turn that layer off. It should look a little something like this. So what we're going to do here is something you've already seen before to get us started. So right off the bat, what I'm going to do is define what my subdivisions are going to be, but I'm going to do it to set it up for glazing, basically. So I'm going to do a divide domain squared, and then I'm going to do a, I'm blanking on the term, construct domain squared. So let's bring those in now. I can do divide domain squared here, and then I'll do construct domain squared. And both of those are going to require a isotrim or subsurf. So this is the general configuration here, and I'm just going to go through and start plugging them in and dropping some sliders. So surface goes here, here, here. You can see that that starts subdividing. The subdivided surface gets plugged in there, and that gets reparametrized, and the domain gets plugged in here. And then I have my sliders, and I'm just going to do all 0 to 10s for my subdivisions right now. My suggestion here, in case you're curious, my suggestion is to actually use, assuming you created your surface in the same direction mine is, make your horizontal subdivisions, which in this case for me it's V, make them 10 subdivisions, so every single one of them is going to be 10 feet high. And the other subdivisions don't really matter all that much, but I'm going to make mine relatively rectilinear. So maybe just like 6 or 7 will be fine. You could even go less, make them wider than they are tall if you want, but the idea is that we're simulating something that has a lot of a lot of data. That would take a while for you to do. So that's why I went higher. And then the subsurf, I got to use my proportional sliders here. So it's going to be from 0 to 1.00. Did I ever show you guys the organization of like how to organize these things cleanly? Those little buttons. Well, if you notice when you group select something, these little boxes, I should have taught you this a long time ago, but these little boxes here are ways that you can start to align things. So if I did these arrows that point all to the left, it's going to align them all to the left side. It's just a nifty thing to help clean it up a little bit if you care that much. So make sure that your maximum is higher than your minimum, obviously. And I'm going to do just slightly less than, I'll turn all these off so I can see what's going on, but I'm going to do just slightly less than the max and slightly more than the minimum. So that's going to be something like a 0.99. I'll start with a 0.99 on both. And then this is going to be a 0.01. Cool. So that gives me glazing with a little bit of a gap.
Okay, just have one question. The surface,
Yes.
you set it to the surface on the Grasshopper. Did you set it to the surface on the Rhino or the
Yes.
whole box? Okay.
Just the surface I created. This one right here. Yeah. Okay, so I'm going to pause and make sure you're all caught up before I continue. So now where I want to get you to at this point is I want to get you to set up the surface box in a position to locate your hardware. And then we'll do the locating the hardware part later. But basically, the first part of this is you take these surfaces and you can set up your surface box directly on them, right? Because surface box doesn't have to be on a morphological surface. It doesn't have to be on a subdivided surface either. It could just be on one particular panel or on a list of individual panels. So we're going to go to transform and morph, and we're going to use surface box. But what we're going to have to do here is break down this subdivision a second time, right? We're creating a secondary surface that's going to be in a particular position on each one of these panels. And it looks a little bit like this. I could just copy this, and I'm going to kind of move it downward here so you can see a clear distinction between the two systems. So I just created a duplicate of exactly the same surface, right? So it goes from, I already reduced it 0.1 and then, or 0.01, and I'm also reducing it 0.01 again right now. But that's not exactly how I want this to shake out, essentially. What I want it to do is to go back to the 0 position, the 99. Oh, you know what, actually? I think I wanted to do this off of the original non-scaled surfaces. Yeah, sorry. I want to do this one off of the non-scaled surfaces. So that would be this right here. I totally lied to you guys. So make sure that you move it back to this one. And the reason is when I'm doing my hardware, for instance, I'm going to have, I'll draw it on the board. If I have glass panel here and glass panel there with a slight empty condition in between, I want to have my hardware actually go out to reach from a center point. And it'll reach that glass from the center point in between them. If I did it from the panel itself, then these would have a gap in between them as well, potentially. Does that make sense? Okay. Okay. So from here, we're going to use surface box, and I'm going to plug my surface into S, or surfaces. And then I have to determine the surface domain. Domain squared parameter, which I'm not sure if it can just be this. I think it can just be that. Yeah.
Yeah, because mine was reading an error, and when I plugged in the domain.
It is?
Yeah.
An error?
Oh, and then it went away after I connected the domain.
Oh, okay, yeah. And then the height is what you're going to determine. So right now I'm going to put a slider from 0 to, let's see, this is probably going to be inch based. So I'm going to do it from 0 to 12. And I'll plug that into H. And remember, these are inches now, not feet. So make sure you put your expression on there that says divided by 12. So H expression, x divided by 12. Okay, so now I'm going to look at it from the back side here so you can really see a little better what's happening. The surface box, and I'm going to start at 12 inches here. You can see it, see the relief? The surface box is used to locate where the particular hardware is going to go. So if I want a hardware connection to be at approximately 10% down, right? So like this is all proportional right now. It's not actually measuring the mathematics of it. So 10% away from the intersection point, we need to reduce these numbers. So I'm going to reduce this to 0.9. Actually, oh, that's right. So my U's are horizontal for me, so those ones I want to leave maximized right now. Sorry. So it's the V that I want to reduce to 0.9. You can tell my surface is upside down because the maximum is at the bottom. Yours might not be that way, but anyway, so that's part of it. I used 0.9, so it moved it 0.9 away from the bottom of my surface. Now I need to determine what the thickness of the hardware connection is going to be. So if I want it to only be 10% of the panel's height wide, then I would use 0.8. So here we've established the height of that hardware piece, and now I need to establish where laterally across this particular box or surface that I want it to be applied. And so for me, I'm going to do from U minimum 0, I'm going to make sure it goes 0.15 away from the edge. Okay, and that's looking pretty square right there. I kind of want it to be a little longer, so I'm going to do a 0.2. So here's the key, guys. Notice how this is doing this to all of the panels. And the cool thing about using surface box in this instance is that if it's a warped surface, it's going to work as well. Because a warped surface, when you do surface box, takes the datum line in between the two boxes. It twists them into one another. So anyway, this is essentially how you establish the box where the hardware piece goes. And if there are no more questions, I'm going to make sure you're all caught up and then move into actually applying the hardware to it.
Okay, mine came out as rectangles, and they're on the left bottom side.
Okay, yeah. So the place that it's at, if you used exactly the same numbers as me?
Yes.
Yeah. So the place where it is on the surface has to do with which direction your surface is facing. So mine, if you realize my Vmax, like I said, my Vmax, I reduced it 10%, but it went up instead of going down. So that means that my surface is flipped vertically. Yeah. Okay? All right.